Okay, I would like to continue with the person example. Guys, shall we? All right. I'd like to continue with this person example here. In the tutorial videos for the next week, I'm going to go over a different example with all the same concept. I think it's really important for you to strengthen your understanding by following both. It's quite a new concept for you. So for those of you who haven't done OOP in Java, it's really important to follow both. Hello, people at the back. Okay, let's now just go a little bit, let's review very quickly what we talked about last time. Basically, whenever you declare a new class, you can have different sections to define in the class. So what we talked about last time, to characterize a person, you might say each person has an age, a nationality, a weight, and also a height. And then we also talk about defining a special kind of a method here. It's called constructor. Okay, so now constructor over here that we talked about last time. One thing to know, let me just switch to iPad now, just to show you quickly. So that's the constructor we defined last time. One thing to note, you can see the name, this is the name of the constructor, which must be the same name as the class, okay, as we said. And then we're going to say over here we got the list of input parameters, so this is called input parameters, also as we said. Okay, we got input parameters over here. Okay, which means every time when you want to call this particular constructor, you have to give this many inputs, okay? In the tutorial videos, I show you a slightly more complicated version where you have multiple versions of the constructor. That's something you can refer to the tutorial video. In the class, let's keep it simple since we got limited time. Every time when you want to construct a person, you have to give a new age, and over here, the choice of the name is really up to you. I deliberately chose a name that does not clash with, for example, the age, right? However, you can do it by using a special keyword called this. That's something I will go into for today as well. Okay, let's just review very quickly what's going to happen here. Now, I want you to look at this, okay, very carefully here. I want to look at these two lines, which we traced very briefly last time. Let's review again. Every time when you want to create a new object, basically whenever you're creating a class, it's just a template. From a single template, you can create as many instances or objects as you like at the runtime. Okay, so now we're trying to use the new keyword twice, which means we're trying to create two new objects of type person. But how exactly do we create? So now let me go a little bit lower level over here to show you, because what exactly is being stored in the variable over here is really important to notice. It actually has a different meaning as what you learn in the elementary programming. Okay, so now what I want you to imagine is, let's say this part over here, okay, let me just draw it a little lower. So this part over here is the computer memory, okay? And then computer memory is simple, you just got a sequence of bytes, okay? Basically just got different spaces for you to allocate different stuff to store. Every time when you actually try to use the new keyword, that means you're going to allocate a new region in the memory for you to store the new objects, okay? Whenever let's say for the first one over here, let me use a different color here. The first new keyword I'm using here, I'm creating a new person object over here. That means I'm allocating some space in the memory over here. Let's say just this region over here, okay? And then I'm trying to store a person object over here. And then I'm going to say the age over here, the age should be 45, the weight and the height, etc. Let me just put a number down. You got 45, you got 72, you also got 1.72. So this information will be stored into the memory. Okay, what's really important, Not only that, the attribute values are important. You got 45, you got 72, you got 1.72. There's another thing that's really important, okay, over here. Every slot in the memory has a particular address that's unique. For example, it could be 0611. Okay, I'm making this up, just 0611, just in binary form. When I declare this particular line over here, let me write it down again. Okay, when I say person and then Jin is assigned to new and then person, and then with some value over here. That's a general form. When I declare the variable Jim over here, and then what exactly do I store? That's the critical thing. Let's review very quickly what you learned in elementary programming. When you declare integer variable x, we know that x can store any integer value, for example, 2 or 3 or 4, and etc. And also same for Boolean and also character. But now, when you declare Jin to be of type person, person is simply some existing class. So what do I really mean? What I don't mean to store is all the numbers 45, 72, and 1.72. That's not the numbers I'm going to store. That's too much. Because in general, your object structure can be arbitrarily complicated, so you just don't have that much space to be allocated for this particular variable. The only thing I store is this particular address over here, which I'm going to highlight over here. Let me just use a better color here. The only thing I store is the starting address of the new objects that's being created. That's the only thing I store. So what you can think about is like this. So I have this particular object variable called Jin, and then what I store inside is just the address of the objects, not the contents of the objects. In this case, that'll be 0611. Okay, that's what's happening here. So now a very common misconception would be, whenever I ask you about what's really stored inside Jin, it's not really the contents of the attributes. It's not. It's only the starting address. It's indirect. Okay, that's it. Okay, let me do another one. Let's say when we make a second call to the same constructor, when I say new here and then person, right? I'm basically allocating a separate region in the memory, separate. Okay, just separate. And then I'm also creating a new person object over here with 62, 65, and 1.81. So 62, 65, and 1.81. And then Jonathan, as you can see, is also declared to be of type person. And what do I store in Jonathan? I don't really store these three numbers inside Jonathan. I don't do that. Okay? I only store the starting address for this new orange object in the memory. So I'll just make up the address quickly. 0623, for example. Okay? So you can see the starting address between the pink and the orange are different. So that simply means there are different objects in the memory. Okay? So now what we have is Jonathan over here. Okay? It's simply an object variable over here. And then it's simply going to store 0623. Okay? That's what this assignment will do. Okay? That's the number one critical thing for you to remember. Whenever we try to create a new object, we're only storing the address of the new objects into the variable. We don't store the contents, because the contents can be arbitrarily complicated. So now, let's do a very simple comparison over here. Okay? A very typical comparison could be, if after these two lines, and you can also see that in the tutorial video, if I simply ask the following Boolean expression, I say Jin equals Jonathan, for example. So what am I comparing? What I'm really comparing are the two address values. I'm really comparing this address value over here and this address values here. Apparently they're different, simply because they belong to different objects in the memory. So this will simply give me false. Okay? So this is a bit lower level picture for you to understand. But from now on, we're going to trace in a slightly more intuitive way. The way I'm going to draw the objects is going to be like this. As always, because the object variable is only storing indirectly the address rather than the object contents. So this is how I'm going to draw. I'm going to redraw it in the next slides. I'm simply just going to say Jim is simply pointing to a new object over here of type person. And then with all the attribute here, similarly, Jonathan is just going to be another object, and then Jonathan is also going to point to that particular object of type person. They're just different. Okay, that's how I'm going to draw. But I want you to really keep in mind, whenever you talk about variables of type a class, It's only storing the address. Okay, it's really important because once we go to the more advanced concept towards the end of the week, towards the end of the course, we're going to use the addresses a little bit. Okay. Okay. Any question about this? Okay. This is a little bit like a new thing adding on top to last week to Monday. What I would like to do now is to show you a very important keyword called this. Okay. We need to understand exactly how this actually works. Okay, and then we'll go on to define other methods. Okay, I will go back to Eclipse over here. I will show you if you're following the code last time. So now let me show you this. Let me just maximize this first. Okay, you can see the choice of the name of the variable is simply new age and also new weights and new heights. They don't clash with the attribute name, which is good. However, there's a better way to do it if you're experienced enough. You don't really want to always come up with new names for the input variables. Guys? Okay. Now, let's think about how we can, let's just go back to Eclipse over here. Now, I want to do the following. I can definitely say every time I want to create a new input variable, I simply don't have to come up with a new name. I want to say, for example, this input variable is going to be used to reassign, to initialize the age. So I can simply say age over here. Okay? And also the double over here, rather than saying new weights, I'm going to say weights. And here, rather than saying new heights, I'm going to say heights. You can see immediately what's going to happen is, you can see we have two, it seems like we got two copies of the age. We have the age over here as an input parameter. We also have the age being the attributes. So there seems to be some ambiguity over here. So that's why you have to use this keyword to disambiguate. Okay? So now how can we do that? Let's see this. So now let me just change it to age as well on the right hand side, and also weights and also heights. Okay? Everything compile. However, if you look at what we have right now in the Eclipse, it's going to give you some warning, which means it's not exactly compiled to an error, but it's going to be just a warning. The warning, maybe the font is too small. I'll just read it to you. If I simply read it out, it simply says the assignment to variable age has no effects. Basically, it's because when you consider this line number 25, we're simply assigning age to itself, which is not what's intended. We want to assign the input age to the attribute age. That's what we want to do. So now how do we do it? Let me show you exactly the right way to do it, and then I'll trace it together with you. What you have to say is this.age, and also this.weights, and also this.heights on the left-hand side. Whenever you say this and dot, that means you're referring to the current object that's being created. And then you want to go to that particular attributes field and then assign the value. Okay, this is how you do syntactically, but let's now trace it very quickly for you. Okay, so now that's exactly what I have just done. And then notice that I'm using this over here, this, and this. Okay? Since I'm using this, I want you to pay attention to this particular line, just for example. If you look at this line here, I have this.age versus age. Which one is referring to which variable in the class? Okay? First of all, when you say this.age, that means you're referring to the attribute called age. So this is really referring to this particular age over here, number one. Okay? So when you use this keyword, that means you're referring to the attributes. And on the other hand, when you have age over here, there's no this. So that means it's referring to this particular parameter. Okay? They are different. So this is exactly what we intend to do. We want to assign the input age, for example, 45 or 62, into the attributes when we create a new objects. Let me trace one particular call, the two particular calls for you very quickly. Okay? So now what I would like to do is, I would like to trace these two lines together with you. It's basically the same object creations, but now we're using the keyword this. We want to see exactly how this can be done. Okay? Again, you can see that we are using a new keyword over here. That means we're creating a new object. Okay? What particular type of object are we creating? We're creating an object called person. That means we're going to execute this block of code for the constructor. Okay? So we're going to execute this block of code, and we're going to create a person object over here, this. Okay, person, and we know that for every person we got 1, 2, 3, and 4. We got 4 attributes. So later on, when you get more many objects being created, you want to know how to draw using rectangle. You can see the detail about how to draw in the slides. Okay, so we got 4 different attributes over here. So we got A for age, M for nationality, W for weights, and H for heights. Okay, so these are the 4 attributes. And then, as we said before, 45 is going to be passed as the age. So age will be 45. Okay? And also 72 will be the second one, which is going to be here, 72. And also the height will be 1.72, so 1.72 over here. Only this particular call. You can call the same method for as many times as you like. Every time you call the method, you will simply give different input values. Okay? So now, let's see for this particular block, how do we trace? Now, how do we understand this over here? How do we understand that? This over here simply means the current object that's being created, which is exactly this object over here. We know that we are creating just this particular object. So this is the object we are talking about. So this is simply the pink objects. And then we say this.h, which is referring to this particular, let me just use a, okay, this.h is referring to this particular field. And what do we want to assign that into? We want to assign that to 45, because you can see the h value here is 45. So h here is 45. Okay? So now when you say this.h, in this particular case, is assigned to 45. This is the current object that's being created over here. And then .h is going to go to the this particular attributes and then assign that to 45. So that's this particular assignment over here. Okay? And then we also have the second one. So all the this over here referring to this particular object is being created. So we're going to say weights would be 72 and also height would be 1.72. So 72 and also 1.72. That's what we will do. And then once we create a new object over here, what's going to be stored in this particular variable? Only the address. So the way we're going to draw it is going to be Jin pointing to this object here. Okay? The same idea as before. The only difference is now you have this.h versus h. So you want to distinguish between the two. The second one is going to be going to be a similar fashion. If you try to execute the second one over here, we're also going to create a new person object over here. You just create a new person here, separate objects. So now we're going to execute this block of code for person constructor for the second time, right? And now this time it's going to be 62, 65, and 1.81. So age is going to be 62, and also weight is going to be 65, and also the height is going to be 1.81. I use different color just to denote it's different calls to the same constructor. Now, when we try to do this over here, when I say this.age is assigned to, you can see that now the age is simply 62. So now what's this? This now means a different object. This is basically the object that we are trying to create right now, which is this orange object rather than the pink one. So every time when you're creating a new object, the object that's being created is called this, the context objects. Okay? So now in this case, what we're going to do is we're simply just going to divide the objects into 4 regions as before, because it's simply a person. So we got age, we got nationality, weights, and heights, and this time it's going to be 62, right? It's going to be assigned to 62. And then it's going to be 65 here and then 1.81. And what do we store in Jonathan eventually? Just the address. So Jonathan is going to indirectly pointing to this object over here. Okay, the same idea as before. That you want to be, you want to get used to how to use this. Okay, when you look at the video for this week, I also try to present this keyword in a more thorough fashion, so you can also look at the video. But hopefully that's concise enough for you to get the intuition. Any question about the keyword this?
So that's the second version of
You mean second version for the constructor? Yeah, so you can see there are 2 ways for you to do constructor. Number one, back on Monday, you can choose the name of the parameters to be not clashing with the attributes. You can just choose unique names. In that case, you don't have to use this. Okay? The second version over there, which also works, you simply got, for example, age over here, which clashes with the name for attribute age. In this case, you don't want any confusion. So that's why you have to use a keyword this. Okay? So now, from now on, I'm going to use this keyword very often because you realize using this makes it easier for us to trace the code. Okay? So let's now go on to develop the code. So now we have covered attributes, we have covered constructors. We have also covered how you can create new objects. So what I would like to do now, there are two kinds of methods you want to define. Okay? Let me just write it down quickly, and then we'll do each one of them. I want to at least give you a complete example today. So there are two kinds of, we just talked about constructor. Oh, let me just move it a little bit lower. We just talked about constructor. Constructor is really for you to create new instances, new objects. Okay, that's constructor. And we're going to talk about another two kinds of methods. One kind is called accessor. Accessor method. Okay, I'm going to talk about it in just a moment. And also the other kind is called Mutator method. Okay, first of all, don't get too stressed out by the special names over here. You get used to it eventually. Think about what's really a method in Java. Method in Java is simply just a named block of code that you can call. It's simply just going to be a block of code like the main method or like the constructor you can call by its name. Now, the difference between accessor and mutator is really crucial. Okay? Accessor simply means you just want to inquire or ask a question. Inquire about the objects. In this case, the person. Which means you don't want to change anything, just ask a question. And mutator, literally speaking, is just going to mutate or change something, which means you want to modify something. Modify specifically the attributes. Okay? So this is just a general principle you can apply to every example you're going to do for OOP. But let's apply this to our person example quickly. I got one accessor and one mutator to show you. And then we're going to see how we can make method call when the context objects are different. It's really important to see everything working together in a small example. Okay? So I'm going to do the first method. Let's do accessor first. Let's see how we can calculate the BMI of a person. So you're all familiar with the BMI calculation from your previous lab. It's going to be the weight divided by the square of heights. Okay? So now let me just do that in Eclipse first, very quickly, and then change the tester, and then we'll trace the code together. Okay, first of all, let me just, so we are still within this particular class over here. Okay, so now I'm going to have a different section in the same class. So now I'm going to do accessor. Okay, let me put a comment over here, accessor. Okay, accessor, oh, one more thing. Every time when you define a method, this is the syntax you have to be familiar with. Okay, let me just show you the skeleton. Whenever you're defining a method, which can be either an accessor or it can be a mutator, doesn't matter. Either one. Okay, this is the syntax. You have to first of all give a type. Okay, so this is a so-called return type. Okay, and then followed by the name of the method. And then followed by opening parentheses and closing parentheses. Inside, you can have a comma-separated list. Comma-separated list of inputs. Each one of them is going to declare some input variable, like what we saw in the constructor. So that's the, let's do one example right away. What about get BMI? Get BMI is going to be the name of the method. Okay, I'll just say the name, get BMI. What about return type? What's going to be the type for a person's BMI? It can contain some fractional parts. So I'll simply say it's going to be of type double. Okay, the return type over here, for now, to keep it simple, it can be whatever type you learned about in elementary programming. It can be a character, it can be a Boolean, it can be a string, or it can be a double or integer. Okay? Later on, we're going to see the type can be also arbitrarily complicated. For example, it can be a class name, or it can be an array of something. Okay? That's something we'll see. Now, what about input parameter over here? That's something we'll see in just a moment. Okay? For the case of get BMI, we simply don't take any extra input. You can get a BMI for a person just based on their weight and height already. You don't need any extra input. Okay? So in that case, that will just be empty. Okay? Let's see exactly how we can define this in Eclipse quickly. What I will do is I'm going to say return type is double, okay, type double here, and then get BMI, and then I simply say empty list of parameters, okay, empty list of inputs, and then I'm going to say curly brackets like that. As soon as I say that, it's going to give me an error, which means it doesn't compile. I want to show you a very simple strategy to make things just compile to begin with. Okay? If you just move your mouse over, I'll read it to you. You simply say the method must return a result of type double, which means this particular accessor method, you claim that it's going to return a double, but you're not returning it. Okay? So that's something you want to get used to. For those of you who are beginning to do OOP, I would suggest the following pattern. Okay? First of all, declare a variable to begin with. Declare a variable that's just going to be of the same type as the accessor method over here. Because we are trying to return a double, simply declare a double variable. Okay? And then double, you can name it in whatever way you like. I'm going to say the result. Okay? Result, and just give some initial value. For example, 0.0. And then that's the first line. In the first line, always declare a variable that's the same type as the method return type. And then the last line is going to be return that particular result. Okay? And this will at least make sure your method compiles. At the moment, every time you call the get BMI on any person, it's just going to return 0 at the moment. What you really want to do is to do something, to do some meaningful computation inside the method. Okay? So now this is where you have to do something. Okay? Over here, you're going to say do some meaningful computation, such that result is being returned is going to store the correct value. Okay? In this case, how do we do the BMI? We can simply weight divided by height square. Okay? I'm going to use the this keyword to show you. Okay? So I can say over here, result, which I'm going to eventually return, is simply reassigned to this dot weight divided by this dot height multiply this dot height. Okay, I'm going to show you exactly how it can be traced in just a moment. It's going to be very intuitive to you. Okay, later. Okay, so everything compiles, only 3 lines of code. Again, whenever you try to define an accessor, this is how I would suggest, especially in lab test number 3. You have to define a variable of the same type as a return type. And then the last line will just be a single return. For those of you who are experienced, you may have multiple returns. That's okay. But for those of you who are beginning, I would suggest have a single return saver. Otherwise, it might be trapped in some compilation error where you have multiple returns sometimes. Okay, let's see how we can trace this particular line over here. So this is exactly what I have just defined. Okay, by the way, in the code over there, in Eclipse, I simply say result. You can feel free to rename this variable to whatever name you like. Okay, you can simply rename it to BMI or whatever value you like. Okay, so when you look at the code over here, I simply call the variable BMI. Okay, it's the same idea. Okay, doesn't matter what the name you call that. So now let's bring everything into context and see how we can trace the code. I'm going to assume that I have 2 objects being created. Okay, I have Jim being a person. Okay, I do have this particular object here for Jim, which we did previously. We also have another object over here for Jonathan, which is the orange object that we have over here. Okay, let's assume that's the one we learned previously. Okay, we got 2 objects. Now, I want to draw your attention to 2 lines, 2 expressions. Okay, and then I'm going to explain. Number 1, if you look at this, Jim.getBMI. Number 2, Jonathan.getBMI. Okay, these two expressions, it seems like we're calling the same method. However, the objects upon which we're trying to call the methods are different. Okay? Let me just enlarge this in another page and show you quickly. Okay? Basically, what we are doing over here is we say Jim dot, okay, it's dot over here, get BMI over here. That's the first expression. Number two is Jonathan dot get BMI. Okay, let's look at these two expressions together. It's really important to see what they are in common and how they are different. Okay, what they are in common is they're calling the same method. Okay, you can see over here we are basically calling get BMI and also get BMI. Okay, so for this part I can simply say, just for this part here, we are really calling. Oh, okay, let me just go a little bit lower. So we are basically saying calling the same method twice. Two times. And you can see that we are trying to use the dot notation. Every time you're trying to use the dot notation, that simply means you're going to somehow look at the store address in the object variable and go to that particular memory location and do something. Okay? Let's see, that's exactly what that means. Okay? Now let me just introduce some very quick term to you. You can see the Jim over here and also Jonathan over here. Apparently they're different variables. Okay? Let's see how they are called. Okay? Let's clarify the term first. So Jim over here and then Jonathan over here. Okay? So these are context objects. Context object in the sense that when I'm trying to make this particular call for the first one, the context object is Jim. When I'm trying to make the second call to the same method, the context object is Jonathan. Okay? Even though I'm calling the same method, the effects might be different because the context objects are different. They are in different memory location. Okay? And now one more thing to say. When I talk about the dot over here, okay, I have the dot over here and I have the dot over here. Guys, would you keep quiet? Can you? You. All right, thank you. Okay, so now the dot notation over here, let me just write it down what that means over here. So the dot over here, it simply means we're going to locate the corresponding objects in the memory. Okay, I'll show you exactly what locate really means. Remember, for Jim and Jonathan, let me remind you very quickly. For Jim and Jonathan over here, they store addresses only. Okay, which means if you only look at Jim and Jonathan, they don't really contain the weights and heights. You have to follow the address and go to the memory location to see what the weight is and what the height is. Okay, that's how you understand the dot notation over here. So now I would like to go back to this code over here. Let's trace it all together. Okay, now let's try the first one. The first one over here, I'm trying to say, I'm just declaring a variable over here. One thing to note, when I say Jim.getBMI, because it's an accessor method, which means it's going to return something, I can always store the return value from the accessor method call. So now in this case, you can see the accessor method getBMI is going to return to me a double. That means I can use a double variable to store it. Right? You can see the double over here correspond to the double over here. Okay? If I simply change this double over here to be a string, you're going to get compilation error because you cannot store the double return value into a string. Okay? It's very straightforward. Okay, so now let's see for the very first call. How do we trace this particular expression over here? For this particular expression over here, Jim is the context objects. Okay? Jim is the context object, CO, for context objects. That means when we are trying to execute this block of code for the very first time, okay? So this is where this keyword can be useful on helping us to trace. Whenever you're trying to trace the method call, first of all, understand what the context object is. In this case, the context object is gym. That means replace every occurrence of this keyword in the definition by the context object gym. So what do I mean? When I say this.weights in the definition, I'm going to replace that by gym. When I say this.weights, also replace it by gym. When I say this.height, and also gym over here. So I replace the 3 occurrences of this by gym. That's what I'm doing here. Okay? That's for the very first call. So what would that go into? What would that boil down into? Think about when I say gym.weights over here. Okay? Again, let me just repeat a little bit over here. We know that gym over here, only this part, it stores the address of some person objects. Okay? The gym alone. And then the dot notation over here is going to locate the objects in memory. And then, how do we locate it? You can see gym is over here. When I say gym is just the address. When I say locate, I'm going to follow this particular arrow over here, and this is the object itself. This is the objects. Okay? Once I reach the objects, I want to go to the weights over here, which is going to be 72. So that's what I will get. So gym.weights will just be 72. Okay? For this particular call. And similarly, gym.height is going to be 1.72. Okay? Let me just go back here. So it's going to be 72. So it's going to be 72 and then 1.72 and 1.72. That's for the very first call. Replace every occurrence of this by the context objects. Okay? So now, I would like to talk about the second call. What about the second one? If you look at the second one over here, we are again calling the getBMI method, which is the same method, the same block of code over here. But the only difference is now the context objects is different. It's now Jonathan rather than Jim. So we are really talking about a different objects over here, even though we're calling the same method. Okay? The context object is really important. So now what do we do? So now for the second call of the same block of code, we have to replace every occurrence of this by Jonathan. So what do we do? You can say this is now going to be Jonathan over here. And also this over here is going to be Jonathan. And also this over here is going to be Jonathan. Okay, you can see the pink color over there was the first call. The pink one is the first call. And the green one is the second call. You can see we are basically following the same pattern of computation. It's just that the this is replaced by the context objects accordingly. That's a very important insight into OOP. Okay? The context object is going to determine everything for your method call. So now let's see exactly what's going to happen here. For example, so now for this particular one, we're going to say Jonathan.weights. So Jonathan.weights. So what is that going to be? Again, if you only look at Jonathan alone, okay, there's a dot, I'll draw it more clearly. Okay? If you only look at Jonathan, this is just the address of some person objects. When you go to the dot, that means look up the address that is stored in Jonathan variable and go to that object in the memory. Okay, so this will be to locate the objects. So how do we locate it? So Jonathan is this address over here. Locate means follow the arrow over here. That's why I draw the arrow. And then you're going to get this particular object over here, which is different from the object you will get in the first call. In that case, Jonathan.weights is going to give you 62, right? So that is going to give you 62. You can compare that in the first call, it will be 72 for Jim.weights. For the second one, it's going to be 62 for Jonathan.weights. So that means the getBMI is going to give you a different result. Any questions for this? The main thing for you to really understand is as follows. Every time when you're trying to make a method call, okay, you always have to first of all see which block of code the method is being called, first of all. And then go to that particular method over there and then see what the context object is. If the context object is Jim, replace every occurrence of this by Jim. Otherwise, replace every occurrence of this by Jonathan. And then, that's why drawing is very important, so you will know exactly which value to look into. This is only about having an accessor call, which means we don't modify the weights or heights for the objects. But now we want to go a little bit more complicated, a little bit more. We're still going to define method, but now this kind of method is going to modify the attribute value. Because if we always can only ask questions without modifying the attribute value, it's going to be very boring. Okay? We're going to see how this can be done. Okay? But the tracing is going to be very similar. You always got context objects. You always got methods. Okay? Okay, let me leave it for the accessor. Okay? What I would like to do now is go back to Eclipse and show you the last kind of methods you're going to do. Okay? The last kind is called Mutator. Okay, it's called Mutator. Okay? For the Mutator over here, we're going to see how we can define it. For the Mutator, the important syntax for you to really remember. The Mutator is going to just modify the attribute values without returning anything. Okay? So that means you're not going to return anything. They have a special keyword for not returning anything. Okay? You have to say void. Okay? I mean, just say it here. With a void being the return type. Okay? Void simply means the method is not going to return anything at the end. So that means you don't have to say any return at the end. You only say return for the accessor. But you don't say any return for the Mutator. For the Mutator, you put void as a return type. So now, let me just say this. I want to do, let's say, a simple Mutator method. Let's say each person can gain some weights. I can say gained weights by some amount. In this case, I need some input value for me to actually to know how much weight do you want the person to gain. Okay, so I'm just going to say double over here, just declare some input variable here, double, and then I would say amount, the amount to grow, to gain for the person. Okay, notice one thing here. Even I didn't say any return statements over here, and then everything will just compile. For Mutator to compile, it can leave the body of the method just empty. But for accessor, you must return something that's compatible with the return type. On the other hand, if I simply say return -1, for example, it's going to be a compile time error because it is not expecting to return anything, but now I say I want to return. That's also not right. Okay? Just remember. So now for the gain weights bytes, what should I do? Again, let me use this keyword. The idea is when I say gym.gained weights by 3, gym is not a context object. I just want to increment gym's weights by whatever the amount is, for example, 3. So in the definition part, I'm going to use this keyword to help me. I can say this.weights. Over here, this again is a context object when I call the method. I can call the method for as many times as I like. Each time, the context object might just be different. It can be Jim, can be Jonathan, can be Alan, can be Mark. So this weight is assigned to this dot weights plus the amount. Okay, this method will be interesting to trace because we got input and also we got context objects. Okay, you don't necessarily have input every time when you make a method call, but you always have a context object, always. Okay, let's trace this very quickly and then we'll see the whole picture. Again, we are basically handling the two-person objects as before. So now let's just do that quickly. So we still got Jim being created over here. That's this person object here. And also we have over here Jonathan. There's a second object that's being created over here. So we got two objects. Okay. So we can do BMI calculation as we did previously. Okay. We can print out what the BMI is for each person. What we want to do is as follows. We want to make the following two calls. I will make it available to you. Number one, I want to say Jim.gain weights by 3. The next one will be, I want to say Jonathan.gain weights by 3. Now, you can see that we're calling the same method, gain weights, twice. You can see gain weights over here, gain weights over here, the same. And then, the amount to gain just happen to be the same, both 3. However, are they going to have the same effects on the objects? The answer is no, because the context objects are different. One is for Jim, the other one is for Jonathan. Okay, let's see exactly how this can be traced very quickly. Okay, so now I want to go to the first one over here. Now for the first one, I'm going to this line here. Okay, when I say Jim gain weights by 3, okay, 3 is the input and Jim is the context object. Context object and 3 is the input. Okay, so I'm basically executing this block of code, the mutator that we just defined for the very first time without any return. Okay, so now you can see 3 over here is simply the amount. So every occurrence of the amount is going to be replaced by just 3. That part is easy. But now what about this? This is going to be replaced by the context objects. In this case, its context object is simply just Jim. Every occurrence of this is going to be replaced by Jim. So what this boils down into is something like, I'll write it out. You basically got Jim the weights is reassigned to Jim the weights plus 3. How do we execute this? The same idea as before. Jim itself is just the address for the objects. It's not the object itself, just the address. Jim dot over here is going to look up the objects in the memory. It's going to follow through this particular arrow. Let me just use a highlighter here. It's going to follow this particular arrow over here for the dot. Okay, and then when you say weights, it's going to go to this particular weights for that particular objects, and it's going to be 72. Okay, so that means for this part over here, Jim.weights is just going to be 72. 72 plus 3 will be 75. That means we're going to reassign that to be 75. That means after this, rather than 72, it's going to be 75. That's how we execute a mutator. You can see it's very similar to how we trace the accessor. Because we got context objects, we also got input parameter. The only difference is, in the case of mutator, we change something. We don't return anything. Okay, let's do another one very quickly. Okay, if we do another one, let's do the second line over here. The context object has now become Jonathan over here. And the input just happened to be 3, the same. Okay, every occurrence of the amount is going to be 3. Okay, just 3 over here, the same as before. And now the context object, every occurrence of this is going to be just Jonathan. Okay, I'll put it here. Jonathan, and then Jonathan here. So now what do we have for the second call? What the second call will do is something like this. Let me just move this up a little bit. For the second call, it's going to be Jonathan, okay, dot weights is reassigned to Jonathan dot weights plus 3. How does this work this time? Okay, first of all, we go step by step. If you look at Jonathan alone without a dot, it's simply referring to this particular address that is stored in the variable. When you have dot over here, that means follow through the address and go to the memory location, conceptually, follow the arrow. And then you will see this particular object over here. And then I'm talking about the weight attribute for that particular orange object. So it's exactly over here. And we know that its value currently is simply 65. So that means I got Jonathan.weights will just be 65 over here. And 65 plus 3 will give me 68. It's going to be reassigned back to Jonathan.weights. Okay? That's going to change from 65 to 68. Okay? So far, so good.
I'm curious why on for the mutators you did sign, why don't you just assign variable equal to
Basically, well, conceptually, okay, thinking this way, for the mutator, conceptually, we want to change any of the attributes for a particular object. In order to do that, we're going to use the this keyword to refer to that particular attributes. That's what we're doing. Okay? Okay, one more thing to mention over here. When you review the source code, if you compare this block of code, okay, this block of code is simply just going to calculate the BMI for Jim and Jonathan. It's accessor call. And then this block of code is simply just identical to this particular one. It's also going to calculate the BMI. However, are we going to have the same console output from the two blocks? The answer is no. because we do have some mutator calls in between. This middle mutator calls will change the return value of the BMI. Okay, that's something you have to observe. Okay, let me see if I do have that in the Eclipse quickly. So now if I simply just go back to Eclipse over here, okay, if I go to tester over here, let me do something very quickly for you. Okay, so this is what we got last time. Okay, let me illustrate this in just 1 or 2 minutes quickly. Okay, let me just do this. Okay, let me just do it for Jim. System.out.println. Okay, I can say Jim.get BMI. Okay, and then I can say Jim.gained weights by 3 kilograms. And then I will just copy the same line over here. Okay, let me just make it a little bit more readable to you. I can say system.out.println. I can say after Jim has gained 3 kg. We want to see the BMI value will change, right? You can see, compare line number 17. Line number 17 is identical to, line number 16 is identical to line number 19. They are identical. However, are they going to print out the same value? The answer is no, because we do have this mutator call which will modify the weights for Jim, the context objects. So if you try to execute this block of code in Eclipse, let's see over here. You can see it used to be 24 something for the BMI, Jim.get BMI for the first time. And then after we have gained 3 weights for Jim by calling the Mutator method, the BMI has increased, which is meaningful, right? Makes sense. Okay, I'll stop here. You can find more details in the tutorial videos.